Hi, let us sit down to discuss two very important AI systems that we have been seeing in the last decade and that have seemed to have a profound impact on the whole AI and technology industry. Not even AI and technology, even cross domain. So they have impacted almost every domain and every industry, and they are a big part of our today's modern AI revolution. Right. So the first system that we talk about is ChatGPT. The second system that we talk about is AlphaGo. So AlphaGo that came in 2016 and then was succeeded by Alpha Zero and then Mu Zero, and ChatGPT, which got famous and released into nearly 20s, right? So or maybe early 22, right? So let us talk about both of them. So let's first talk about the more familiar one, right? ChatGPT, which we also understand as a large language model. And ChatGPTs have been thought of as the next token predictors, right? They are stochastic in nature, they are autoregressive in nature, they have the autoregressive next token prediction, right? So we call them stochastic, we call them probabilistic, we call them that they are known for estimating conditional probability to estimate the next token, right? But one thing that we know what they're good at is they are very good at understanding and processing natural language, right? Along with it, they are also very good at generating code, right? So they are also very good at synthesizing and processing all the human knowledge on the internet, right? And then doing the next token prediction, then doing the internet simulation over them. So why do we call next token prediction? Because I mean, for the larger audience, whenever we think of ChatGPT, we know it is conversational in nature. We have never seen it produce next token or only one token. Why? Because when it produces a token, it auto-regressively generates token after token to generate the whole sentence and further to generate the whole paragraph, right? And it has been made conversation, but the underlying base model is nothing but an X token predictor, right? The underlying base model is still probabilistic, it is still stochastic, right? So we also call it a little greedy, right? It will give you the best coherent and best contextually relevant text, right? The text will have very high amount of confidence, very high amount of probability associated with it, right? Will have very high amount of relevance. But will it be the truth? We don't know yet. Will it be the most logically relevant text, that fulfills a long-term strategy? We don't know it yet, right? So, I mean, obviously it's not, right? The large language models that the GPT uses are not truth seeking. So Daniel Kahneman describes two thinking paradigms, system one and system two. So this is mostly system one thinking, what ChatGPT tries to reciprocate. It cannot do long horizon planning, long term planning, logical planning. Along with it, it cannot do new discovery. Why do I say that it cannot do new discovery? Because whatever it has been trained on the internet and whatever it has read on the internet, it is trying to generate and simulate the same text in the same manner, right? So we cannot expect a model like ChatGPT to come up with new novel scientific discovery and new inventions that human and physics has not seen yet, right? So it lacks autonomous agency in the physical world. So why do I say that? Because it's very logical. It is not itself a autonomous agent, right? That can be deployed in a physical world. It does not even have a physical body, right? So whereas if we just go back to 2016 and see what AlphaGo taught us, and why do we still talk about AlphaGo and why is it still relevant, right? So AlphaGo is a combination, just like ChatGPT is a combination of a large language model. Underneath, there is a transformer that is sitting, that is calculating attention scores for the whole language and helping you predict the next token and helping you generate the condition probability of the next token while minimizing the cross entropy loss, right? This is the math behind the whole GPT model, right? Now, we obviously know that it is not truth seeking, it is greedy, it is not strategic, it has system one thinking, right? Now, let's talk about the other paradigm, which is AlphaGo, so that we can compare one on one. So, AlphaGo's mathematical strategy was contained from deep neural networks, from deep learning, along with something known as MCPS, Monte Carlo Tree Search, right? It's a very famous algorithm. So now we can use Daniel Kahneman's framework of system 1 and system 2 thinking. Here, deep mind does system 2 thinking, which humans are great at, right? Which is obviously slow, it is logical and effortful, and it is objective driven, right? So AlphaGo is a system or an AI system that was designed to be great at the game of Go, right? And it beat almost every human being that was best at Go, and it became like one of the best AI system to play Go as a game. And Go is one of the most difficult games, right? And there is a very famous story where it discovered a move 37, right? So move 37 is basically a move that got very famous while seeing AlphaGo play against a top tier Go competitor. I think it was a Chinese competitor, and move 37 was a move which it invented itself, right? So people or human beings who were great at Go, all of them were witnessing that game, and they realized that we never trained this AI system on this particular move, and we had never seen this kind of a move. How could it come up with a move itself that is also a successful move that is taking us towards a winning strategy, right? So that is why AlphaGo is thought of, or AlphaGo has a paradigm of system 2 thinking, which is slow, right? Effortful and objective driven, goal driven, right? Now it taught us one thing which is known as self play. So AlphaGo is not based on the transformer architecture. It is not a probabilistic model. So what it does is it has multiple neural networks. One of them is a policy network. The other is value network. Then the other is Monte Carlo Tree Search. So basically, you can think of it as the combination of deep learning, deep reinforcement learning, and Monte Carlo Tree Search, right? So what different networks do? So just imagine that policy network says in 10,000 games, people play these. I've seen people play these three spots. So let me narrow down the search space for you. Now, what is going to be the role of value network? Now, value network has seen that policy network has narrowed down the whole search space from this huge to this huge. Now, network is going to assign, the probability and the reward to each winning state, right? For example, let's say there are three states. It's going to tell you that it is 80% win state. This particular state is 80% win state if I look ahead, right? So what does the Monte Carlo tree search do now? So Monte Carlo tree search simulates future trajectories and explore all the decision trees or all the paths on the decision tree and understand all the high value paths, right? It's a great combination, and it is a simple model that helps us understand that this is how reasoning can be thought of. I mean, solving intelligence and solving reasoning can be thought of with this particular paradigm. So, why this particular paradigm? Because it kind of proved the hypothesis that this is how humans think. Because AlphaGo came up with a move itself, right? And when it comes up with a move itself, although in a deterministic game, it was thought of as a new discovery. If we could see that AlphaGo is demonstrating a very profound thing, which is it is demonstrating a mechanism of self play for generating knowledge. So we could assume that it is capable of inventing new discovery, right? It used to start with a random play, right? Randomly in an agentic environment, it used to have a random play and there was a constant improvement loop, right? And after that constant improvement loop, it rediscovered thousands of years of human knowledge and then kind of developed novel strategies that even humans could not conceive, which was, I mean, one of the strategy was move 37, or one of the move that it took was move 37, which was a big aha, eye-opening moment. Like, what have we witnessed? How can a machine that we programmed using, a deep neural network and a Monte Carlo tree search, how could a machine come up with or generate a move that we could never think of in hundreds and thousands of years? Right? So now if we do a one-to-one parameter wise comparison on ChatGPT and on AlphaGo with respect to the future AGI paradigms, so we've seen that the thinking mode of ChatGPT is system one, right, which requires no thinking, which is a little greedy, which is probabilistic, which is stochastic, whereas AlphaGo is slow, effortful, objective driven, right? So the future AGI paradigm or the AGI paradigm might require us to have system 2 thinking, right? So that system 2 can verify system one's outputs, right? And now what about the objective function? If we compare ChatGPT and AlphaGo on objective function. So the objective function of ChatGPT is minimizing the cross entropy, right? Perplexity minimization, right? Whereas AlphaGo is reward maximization, right? It puts an agent in a system or in a simulation in an interactive environment where it plays and it discovers the winning states. The objective is to win the game, right? With a deterministic set of legal moves, the objective is to win the games, right? So you maximize the reward. If it moves right, you maximize the reward, right? You are always solving for winning. You're always solving for reward maximization. You are not taking a greedy, contextually and coherently relevant token. So just in case of GPT. So now let's talk about what AGI might require. AGI requires engineers to optimize these outcomes and not just mimic text generation, obviously. So AlphaGo kind of favors AGI's paradigm here. Now, with respect to truth grounding. So for truth, GPT does not seek truth naturally, right? It is creating a probability distribution on the training data, right? It is not verifying any output logically, right? Whereas AlphaGo has outcome verification, right? It kind of simulates the future trajectory and sees the probability of a winning state because it knows that there is an objective that I can verify and I can, using my Monte Carlo Tree Search, I can simulate the future trajectory to see if I'm doing fine. Otherwise, I can backtrack, right? So the future AGI paradigm might require the AlphaGo paradigm or the AlphaGo mode where we would need to verify the truth. We cannot avoid the truth seeking paradigm. We need an objective, we need logical truth because let's say if we are solving for scientific discoveries, need truth, right? So here also AlphaGo takes the win. Now let's talk about error handling. So Jan LeCun pointed out that the drift strategy or the drift error, basically he used to say, Jan LeCun is the chief scientist of AI at Meta. Now he left to start his own company. So he said that LLMs like ChatGPT have compounding errors. So they generate tokens linearly as they go forward, and their errors compound over steps, right? So this is what it used to call drifting, right? So he used to say that these LLMs might sound very, very intelligent, but they are doomed. Whereas AlphaGo, the paradigm of error handling with AlphaGo is self-correction, right? So and AGI paradigm also need agents and AI agents like them to be, I mean, reliable AI agents that must operate over long time horizon and that must have their a self-correction paradigm to them, right? So now we know that most of the wins have been taken by AlphaGo when it comes to AGI. Obviously, GPT is much more useful in today's world. If we look in retrospective, it's a great consumer business and it is a great consumer application that we have. We know that while ChatGPT has represented the adoption and is now currently representing the modern AI world, and it has kind of democratized AI across all enterprises, institutions, consumers. But AlphaGo still represents the elevation of AI beyond human limits, right? It still represents that there can be a possibility when an AI system like AlphaGo can potentially do some new discovery, right? It kind of proved that a machine can possess high agency and truth. It kind of proved that a machine may be capable of self correcting itself and coming up with a new novel discovery, right? So the generative modern AI era was very good for the whole knowledge base, but now the new upcoming agentic era is defined by building the reasoning engines, by building the logically reasoning engines that also has truth seeking ability. The new upcoming AI systems that we are talking about, which is nothing but AGI, they might not look like a typical chatbot, but they might look like AlphaGo. So they might act by simulating futures, verifying the hypothesis against rigorous value functions, and optimizing outcomes that no human has yet discovered. So it's like they might search the whole space of physics, right? And they might find a new cure that we might have not, or they might navigate a very complex search space of logic to prove a theorem. But we need them to be truth seeking, to be strategic, to be goal driven, objective driven, so that they can simulate reasoning. and we need them to invent while they are navigating physics. We need them to invent something like a cure to something. We need them to invent a theorem and maybe logically prove it. So the logical answer and the logical conclusion says that or favors the AlphaGo paradigm, the system two thinking paradigm. Thank you. Cheers. I hope you like it.